It's great to be here. This word renaissance is being used in a few different places this morning. That's good to see. I think we're all agreeing there's something interesting and transformative happening in the world of engineering. For those of you that have seen me before here at D3D, this is probably the 6th or 7th time I've been here. And my career actually started in industry. I spent the first 16 years of my career doing what you all do as a product development engineer, mechanical engineering major. And you know, it's interesting, some of the problems that I see today from my perspective as a software engineering software provider are similar to, but also there are some different unique problems that are being touched upon today by everybody that are real and relevant to today. And thank goodness there are a number of new technologies emerging that are helping us all, helping us help you and helping you deliver products to market more effectively. And that's actually, it's very, very unique what's happening right now, and that's what I'm here to talk about. But I want to start at the highest level and say what's happening in the industry broadly that we see is sort of driving this need to be better all the time. And you know, first of all, it's different today than it was when I started as an engineer from a global competitive standpoint. The barriers to entry to get into business globally are much, much lower. And so the competitive forces in pretty much any industry for any industrial product manufacturer are really, really difficult to overcome. You got to be really on your game, right? The ability for new entrants in the markets to get in and get scale is really like nothing we've ever seen before. So competitive barriers are a big problem. You know, secondly, we have a bit of a skilled labor gap issue in the engineering workforce. You know, when I started out as an engineer, I had a guy who grew up in the tool and die shop as a mentor. This guy understood design for manufacturability. He understood how to communicate design intent on an engineering drawing, and I learned it from him. He's aged out of the workforce. And a lot of other people like him have aged out of the workforce. And a lot of young engineers that are getting engineering degrees today have a lot more options today to take their engineering degree into law, into venture capital, into medicine. So there's plenty of engineers graduating at universities just like this one, but not all of them are going into the same jobs I went into and that maybe all of you are into. So we have a challenge with democratizing the knowledge that one of my greatest mentors ever, his name was Joe, his knowledge is really, really important to the company. As he walks out, we want to make sure the knowledge doesn't walk out with him. So democratizing that knowledge into the engineering workforce is really, really important. And of course, there's a productivity issue as well. If you really study manufacturing indices, you see productivity worldwide is starting to plateau. The increases that we're able to make are actually smaller and smaller incrementally year on year, and that is a problem from a competitive sort of go-to-market standpoint. And that's where how you see the impact on engineering, right? So from an engineering standpoint, specifically for all of you that are doing product development, what this means is you've got to be more innovative. You have to be able to figure out how to differentiate your products and services effectively in order to really, really compete. You got to bring those products and services to market faster than ever to capture the moment, to capture the opportunity that you have. That's sort of the far right accelerate the market need. And there's a unique problem here with closing the skilled resource gap that is occurring because of the engineering challenges that we're seeing with so many options for so many engineers and so much process knowledge, manufacturing know-how walking out the door at so many companies that we service every day. So thankfully, there are a number of emerging technologies that are out there in the landscape that can help with these problems. And you know, this is a graphic that's not from a PTC study. This is from a Deloitte study in 2018, just last year. They studied the sort of the industrial product development landscape and said, look, there's 13 emerging technologies out there that are really starting to impact industrial product companies, right? And interestingly, this is part of the reason why I think we are really at a renaissance moment. About 8 of them, 9 of them, depending on how you look at it, do have an impact or can have an impact on design engineering. Okay? The challenge is, and the speaker before me talked about this quite eloquently, the challenge is bringing a point solution to the market doesn't really help. If you've got a point solution that breaks the design process, okay, it's great. You can go and spend some time in another tool to solve a very specific type of problem. Ultimately, it's not going to really be worth it. You have to have these technologies integrated into your core design platform. And if any of you have ever heard me speak about what we do at PTC, you know we don't bring technology to market unless it's deeply integrated into CREO, period. We just don't do it. It has to be on the CREO platform. Otherwise, we feel like it's going to be useless to you, right? And so that's, in fact, exactly what we are doing. And what I'm going to do is use this wayfinder to sort of walk you through what we've been up to. We're investing in 5 major areas across CREO to address those sort of 8 orange circles you see there on the slide. And we're doing it on a single CAD platform that scales all the way from, exhaust systems for Polaris. I actually met that vendor at an event in the San Francisco area a few months ago. All they do is exhaust systems for Polaris. Of course, Polaris is a big PTC customer. All their major stuff is designed in our software, but it goes much, much further than there. I mean, Polaris snowmobiles are, I don't know, a few thousand parts. There are assemblies out there that are hundreds of thousands, millions of parts in CREO, managed in Windchill. It's a single CAD platform that can scale from, exhaust systems for Polaris snowmobiles to a 3.5 million part assembly built by the federal government, National Ignition Facility in the United States. So we can scale with a single platform to whatever your needs are, and every bit of technology I'm going to talk about today will be right there at your fingertips in CREO. All right, so I'd like to actually start with the only bit of technology that I'm going to talk about today that is kind of on the near-term horizon, not quite in there in CREO, and that's generative technology. It's a little hard to talk about design without talking about generative technology nowadays. You got to sort of make sure you address the big innovations happening in the world of generative design. This is one of those technologies that can really help democratize engineering and manufacturing knowledge. It is manufacturing-aware technology. I heard that phrase earlier today. It's very true, and PTC has been hard at work here, but we found a great opportunity to acquire a company called FRUSTUM about 5 months ago, who we believe was sort of the leading technology player out there. We're very, very thankful to have Jesse Blankenship and his team working for PTC now, and we are hard at work making that technology part of the CREO platform. We're not going to deliver you a point solution in generative technology. We're putting it inside CREO. So those of you that know Jesse, he's here today, and frankly, he's the expert about what I'm about to present, and I wouldn't have these slides if it weren't for him. So thanks, Jesse, for that. What I want to do is I want to walk you through a maturity model. There's been a lot of talk about what generative design is and what it isn't, and I feel like we're frankly one of the world's foremost leaders in generative technology now working for PTC. We have the opportunity to define what we feel like the generative sort of design continuum really is, right? So let me walk you through it. I'm going to use a model that you're probably all familiar with. If you're in the engineering domain, you're familiar with the autonomous cars industry, and they use a maturity model that goes like 0 to 5, and I'm going to use a similar type of model to define the generative landscape. So at the very left-hand side, not truly even generative design, we have what we call inspirational, iterative inspirational technology. It's really just, topology optimization without manufacturable geometry. There are technologies out there that do that. That's where topology optimization started. I wouldn't even really call it generative design because it only sort of inspires, if you will. That's where the word is, inspirational, iterative. It only sort of inspires what the actual geometry should be, but the design engineer has to take it from there. I wouldn't even really call that generative design. It's just a base technology piece that is important for generative, but it's not the whole, certainly not the whole story, right? The next level up from that is the first time you see manufacturable geometry. So there's a lot of tools out there that'll get you this far. You certainly can get that far in CREO, where you have your topology optimization results, and now you've got manufacturable geometry that you can carry on through the process, right? But that's still really just topology optimization with a nice twist in that you're getting manufacturable capable surfaces out of it. Really, when you start seeing true first-level generative technology is really at level 2. We're kind of calling it partial generative because now you got the first manufacturing awareness built into the platform. You've got, you can't see it on the slide, but if you look closely, there's 3 different manufacturing constraints applied from the Generate engine that we acquired from FRUSTUM applied there. Just 3 to get started, right? Just to give you an idea. Now, when you're doing this kind of computation, it's mostly probably going to be done on the cloud. It's not a requirement, but it's probably better, more scalable to do that in the cloud. That's why I added a little cloud icon. I am taking some liberties here with my icons. You just have to sort of work with me here, okay? At level 3, things start to get really interesting because you're adding multiphysics into the game, and you're now starting to add some of these genetic evolutionary algorithms that could take 3, 8, 10 solutions and blow them out to hundreds of potential solutions to the same problem. Genetic evolutionary algorithms are something I'm most certainly not an expert in, but we did indeed acquire technology like that when we acquired the FRUSTUM technology, and it's going to be mind-blowing when it gets applied to CREO designs. We're really excited about where this will take us, and frankly, we expect to be here at this level in less than a year when we get the FRUSTUM technology integrated into CREO. So if you're thinking about where you're at today with your design process, imagine being able to apply this in CREO in less than a year from now. So we're headed there really fast. But let me build out the model and start to talk about some really crazy, wild things, right? At level 4, we're almost fully autonomous like Star Trek world here, but level 4 is actually not too crazy. You're adding things like machine learning. Imagine a generative system that can take a look at your database of hundreds of castings that your company has done for years and years and years, and also take a look at enterprise information like cost, design for manufacturability information, maybe process quality information, and learn what does a good casting look like at your company? And then apply that the next time it's asked to do a generative study and include casting as one of the manufacturing constraints. That's what level 4 generative technology will look like, right? So I have a ThingWorx logo here because it's PTC's award-winning industrial IoT platform that can bring enterprise information in from any source for use in, say, a generative study. I also show a little assembly icon here because we expect at level 4 that generative technology can work at the assembly level and propose solutions with multiple part configurations versus just at the part level. Level 5 is, if you're a geek like me, level 5 might be, like the Star Trek simulator world. It's, just give me a coffee cup that does this, or, just I don't know, just give me a laptop. And boom, you got a laptop a few days later, right? That's crazy talk, but you have to have a right-hand scale and a left-hand scale on your scale, right? You have to have a right-hand maturity level and a left-hand maturity level. So you have to have a goal. Think of level 5 as like the fully autonomous, like I got in a car last night at Heathrow and drove here, but there was someone driving the car, right? Instead of just getting in and say, just please bring me to Sheffield University, right? That's fully autonomous car on the right-hand side. You could think of ultimately us all having a goal of fully autonomous generative, right? In the fairly distant future. So back to sort of the level 3, what might it look like in the world of CREO? These are all sort of video shots pulled together of technology from our FRUSTUM acquisition, but I want you to think through what this will look like inside CREO. This should play automatically. Yes, excellent. Right, so just like any other generative solution you might think, when you start out thinking about a generative solution, you have to define loads and boundary conditions and so forth that are the inputs to the generative engine. It just so happens because this is a Polaris assembly that's got dynamics built into it, all that is done for you. All the loads and boundary conditions are all just coming from the assembly, so it's not a problem. Well, now then you have to define the domain. What is the domain that the generative solution is going to apply in? Easy to define. It's just a simple volume around the part we're working on. We're working on this red strut. You've got to have clearance for getting at the assembly points, and you've got to have a notion of what the motion envelope is of the structure around there of the suspension. And so then once you intersect those, now you have the domain that the generative system has to work on, okay? Again, think about this all inside CREO. You're not in a point solution, right? So once you have that all defined, you got everything intersected, now you can go off and have the generative system run. And we did a cool little montage so you can see multiple manufacturing process constraints converging at the same time. Imagine this all running on the cloud. It could run locally, but it'll run faster on high-performance compute on the cloud. On the far left, you see sort of an unconstrained case. In the middle, you actually see a casting solution. I've seen some crazy parting lines automatically generated by the generative engine today that are really hard to model yourself, but the system is smart enough to know where to put them automatically. And on the far right, you're seeing a 3-axis machined example, right? All the stress solutions are all there for you so you can inspect what the results look like. But even more interestingly, as you go through this process of evaluating different designs, I'm only showing you 3 because I wanted you to see kind of some of the detail here. I could have shown a lot more, multiple materials, that kind of thing, all possible with the Generate solution that we acquired from FRUSTUM. But I wanted you to see some of the details and kind of see how clean everything looks. That's straight out of the system as it exists today. Very, very clean, very nice, already coming out of the system. And you can evaluate those on the cloud, take a look at what the results were of the convergence, and then once you pick one, you get it immediately integrated back into your core CREO application on your desktop machine, right? And so the point of having this seamless integration into the CAD environment is a really, really important one. And because these technologies have the innate ability to understand manufacturing processes and even over time learn what good manufacturing processes or good manufacturing parts look like, they can get better and better at democratizing that manufacturing process knowledge that might be going out the door as more and more really senior engineers retire, okay? So that's our generative strategy. You're gonna see that technology in production hopefully next year when I'm here to talk about it and show you a lot more detailed demos. I'd like to move on and talk about simulation. So there's been a lot of talk about simulation today. I think one of the challenges with simulation as part of an engineering design process is how disruptive it can be. It can be super helpful, but for the everyday design engineer, the knowledge of how to simplify a model in order to get an answer in a reasonable amount of time is not obvious to a lot of engineers. And even if the simulation takes 15 or 20 minutes, it's disruptive to the workflow. If you've used CAD for 6, 7, 8, 10 hours a day, you know that you're moving, right? You're making changes, you're evolving your design. You need a simulation technology that can really keep up with you as you design. And we found that simulation technology in the technology from Ansys. It's their Discovery Live simulation technology. It's so fast, it can really keep up with you as you do your design work and provide that design guidance that a design engineer really needs minute by minute as they make design decisions. So we're really excited to already have this technology in production. By the way, everything else I'm going to talk about today, you can see live demoed in our booth. It's production technology. We've already been selling this now for a little bit of time. This is just one customer quote. It's even more interesting to just see it. So again, we're going to use this Polaris snowmobile assembly. This is a demo that we did live when we launched CREO Simulation Live a few weeks back or a couple months back now with Ansys. The first part of this video, what you're going to see is how CREO Simulation Live can keep up with you as you make design decisions and how quickly and easily it can get you answers. So you're never going to see any part simplification. You're never going to see simulation done in a separate environment. You're right here in CREO. And as a design engineer, you do inherently sort of understand, okay, I'm holding it here and I'm pushing it here and I'm pushing with a certain amount of force. And as soon as you hit go, within 2 seconds, you got your answer. Not 5 minutes, not 10 minutes, no simplification. You just have an answer in CREO. So now you have an idea where are the hot spots, where are the not so hot spots with the current set of loading conditions that I have, and you can then go evolve your design. You see the simulation result here paused, but only because I'm in the middle of creating a new feature to address some of the high stresses I have in the model. As soon as I am done, the stress results update. Seconds later. It's like choosing whether or not you have the part in shaded mode or not. It's that fast, right? So fine, the design requirements change. I'm early in the design process. I'm already getting simulation feedback as I design, but I got new requirements. I have new load information. So I'm applying that new load information, and you'll see as soon as that new load information is incorporated into the system, again, the design updates, and now I have a new hotspot. I got a different problem. Actually, the stresses in the area that I was worrying about before, not quite as bad as they are in a new area. So fine. I'm evolving my design, and I'm getting feedback as I go. Every time I make a change, I know whether or not I've improved the situation or I've made the situation worse, and I haven't had to consult the simulation expert once. I'm just there doing my design work as an engineer, right? So I make another rib. I see things that have significantly improved, but all good design engineers know that you don't do a molding, a feature on a molded part without adding some nice rounds, right? We don't want to have sharp edges in our tool. So, okay, we'll add some rounds. You see the situation gets a little bit better, but it's actually not, I know what's going to happen. I've shown this video before, right? Okay, I know what's going to happen. It's actually not going to improve until we move the rib over. We got to actually change the flow of stresses in the part a little bit. So once we move the rib over, then things significantly improve. Okay, so that's what you see here at the very end, moving the rib over, and now things really improve. The point is, not a single time did I have to get up out of my seat, walk down the hall, and ask a simulation expert to help me simplify the model so that I can get an answer 10 minutes later, or 2 hours later, or 4 hours later. I just did 4 or 5 simulations in a matter of minutes, right? Very, very powerful, very reactive, very good guidance. But the power doesn't really come through unless you see it in a bigger scale. This is a fairly large assembly. You can see there are a lot of parts. There are lots of detailed geometry in here, right? There's a lot here. So now we're taking in assembly level loads, flowing those loads through all the parts, and seeing if CREO Simulation Live, based upon the Ansys technology, can help us get an answer very quickly. Well, this one takes about 3.5, 4 seconds. Is that good enough? Does that work? It's pretty quick, right? So now we're seeing the same kind of results, but now in the assembly context, extremely fast and powerful. I mean, imagine how much time it would take you to set up a structural simulation on this assembly with all that geometry. It's going to take you a day, if not more, right? But I get a result very, very quickly. What you're seeing here is we've changed the output from stress to deflection. The deflection in the front right-hand corner is actually about 1 millimeter. It's a little too much, right? Interestingly, I can just resume a bunch of formerly suppressed parts. Simulation just updates. I just added half a dozen parts to the assembly, and boom, I got an update. Now the deflection in that front right-hand corner is about 1/3 of what it was before. Just imagine how much faster you can get products to market if every step along the way you know if your design is getting better or worse relative to your design requirements. Just imagine how much faster the simulation experts that do work at your company will be in doing the final simulation validation when every step along the way you as a design engineer have gotten guidance from this amazing ANSYS technology right inside CREO. You will be faster and you'll produce higher quality products, I'm sure of it. Okay? So moving right along, I'd like to talk about IoT-driven design. You know, I think 7 years ago now, PTC acquired the ThingWorx platform. And you know, I'll be honest, most companies move down a path of IoT-driven design mostly because they moved down a path of using IoT technology, mostly because they want to do a better job servicing, running their operations. They want to integrate data across multiple disciplines. I think integrating data into the design process could be really, really useful. And more, the more companies we talk to, the more we see that. Polaris is another great example of a company that is taking the data from how their sleds are used and using it to inform next generation design decisions. And PTC, since CREO 4, we just released CREO 6, has had a technology called CREO Product Insight that allows you to integrate sensors into the design that are ThingWorx aware, that are IoT ready, if you will. They have sort of receptors for data that can come through the cloud, through our ThingWorx platform, and bring data directly into the design environment so you can gain greater insights into what's happening to your product in the field, perform simulations, and so forth. So here's a great little video.
CREO Product Insight.
No audio. Good one. Wow, that hurt. Anyway, what you're seeing here is a cool little demonstration of a little robot. It's got some sensors in it. Now, you don't have to have models of your sensors. All you need is a part with a point in it and say, this is where the temperature is, this is where the force is, whatever. We happen to showing you actual sensor part assemblies that don't need to be physical 3D models. All you need is the semantic understanding of a sensor in your CREO assembly and you'll be fine. So here we have an angle sensor to sort of track how much the claw is open or closed. And we're going to also integrate a force sensor to track how much force we're clamping down on our parts with, right? And these sensors can then be bound to data streams in ThingWorx, directly from within CREO, by the way. I said it, we won't integrate technology unless it's right there in the CAD environment. You can do this right from within the browser in CREO, okay? So this is what we're doing here. We're doing this binding action here to bind to a data stream in CREO, and now, bind to a data stream in ThingWorx. And now CREO and ThingWorx can work together to take a look at any sort of circumstances you want ThingWorx to look for and automatically run simulations like the simulations you're seeing here based upon whatever conditions you think might be interesting or might be relevant. In this case, the design engineer is walking through the process manually, like gathering the data from the time series data from ThingWorx, running into CREO, running the simulations all manually. You can tell ThingWorx and CREO to work together to do all of this automatically. Just pick a certain set of conditions that you're looking for. ThingWorx will look for those, and CREO will automatically run the analysis on that data, all without your doing. This is really a digital twin, right? This is a video I showed last time. This one would have been good for audio because it's really, no, don't turn it on, don't turn it on. It's really loud, like engine screaming. This is the cool digital twin of a car chassis assembly as a result of running a car around. We had some really good insights. I actually showed that with audio last year. I didn't want to put you through that again. It's really loud, but that's our IoT-driven design strategy. We see more and more companies now realizing, you know, their IoT strategy actually starts in the design department, right? And so that's what we're seeing there. Let me move on quickly to talk about AR. AR technology is another technology that's being widely used in the industrial workplace, mostly to make manufacturing and service workers more efficient. We believe it's really, really relevant and valuable for design engineering for collaboration purposes. And we see, because we host the AR server, thousands upon thousands of customers using our integrated AR technology to allow engineers to collaborate. They're either collaborating with their customers to see if their proposed design concept works well, or they're collaborating with each other instantly anywhere in the world. And we've made a lot of improvements. I think 2 years ago, I did a demo in the room with a big thing mark on the floor in the auditorium. You don't need those anymore. The AR technology from PTC is advanced incredibly. You just tell the system where's the floor, and we automatically scale the experience. Every engineer can manage who sees what experience, and no data leaves your laptop. We're only streaming triangles. So all you need to do is get a link from me. You download a free app from the App Store, or it actually works on HoloLens as well. And you can see here, that's a pretty darn good scale, automatic. That's the real Polaris snowmobile on one side and the AR rendered one on the other. It's one-to-one, fully immersive. There's nothing like seeing your product at one-to-one scale right there in front of you as the design progresses. It's very, very powerful. You don't realize how much you miss just seeing it in 2D unless you experience it in 3D. You can try this out later today. Okay, the last topic I want to talk about is additive manufacturing. This is something I've actually talked a lot about here. This is a place where there have been tons of point solutions. And because additive manufacturing has become more and more interesting, we saw an aerospace example earlier today, a really good example. Listen, it's really relevant to a lot of companies that care about fuel savings. It's even relevant for a lot of companies that are just trying to innovate, right? A lot of it's happening in production, and if it's happening in production, it puts pressure on the design system. The design system has to support it like any other manufacturing process, right? And so when we studied this many, many years ago, and we were thinking about CREO 3, we saw a disconnected process, multiple tools being used for multiple steps in the process, and we said we just can't have that. We've got to have it all inside CREO, and we've done a lot of work here. I actually don't have a video on this because we just released CREO 6, and we took some of these things to the next level. It's really amazing, particularly in the lattice areas. You see up here, we can now do these really, really dense foams. They're called stochastic lattices. If you're really a geek like me, you like that word. Stochastic lattices to do some amazing things with structures and foams directly inside CREO. I got news for you. You can't print that with an STL. So we had to change things on the printer interface side too. That would be a massive, massive file, but you can do that directly inside CREO, not just model it, but you can simulate it and so forth, right? We also built these cool things in CREO 6, these so-called gyroid lattices. They're really important because they're self-supporting. You don't have to worry, if you're making them out of metal, you don't have to worry about support structures. The geometry itself is inherently self-supporting. So we did all that in CREO 6, all this other stuff we've had for quite some time. We have had topology optimization for 2 releases now in CREO, and now it works at the assembly level. It has always resulted in manufacturable geometry from the very beginning. I promised you I would not put technology in CREO that broke your workflow. This does not. But you can, if you're asking the question of yourself, well, what about that FRUSTUM stuff? Doesn't that? Yes, the FRUSTUM stuff will supersede what we have here. That is coming, and it's better than what we have in the technology today, so it's only going to get better from PTC there. We've done a little bit of work on our tray assembly. The tray assembly is the additive manufacturing equivalent of the manufacturing process assembly for machining and so forth. You have to have that. We've done a little bit of work there, and we've done a lot of work actually in supporting 3MF, in particular for these super, super dense lattices. If you want to try to communicate a super dense lattice like that to a printer, you simply cannot do it with an STL. It just won't work. You have to communicate it layer by layer. You can do that in CREO, okay? Again, I won't put technology in your hands that's not deeply integrated into CREO so you can use it as part of your everyday workflow. All right, I'm just about done. I think this was a very quick whirlwind tour through what we're working on in CREO. I do think we are at a moment here in the industry. There are so many amazing new emerging technologies that are going to help you be more effective. It really is a renaissance of industrial design. I encourage you to get started by taking a look at CREO 6. Everything you saw today, except the generative stuff, is there. It's ready. It's in production. You can see it in CREO 6. And we're so excited about our generative program. We're starting an innovators program. If you're interested in participating in that, it's a small sort of invite-only program for working with us on evolving the technology as we bring it to market. And if you're interested in that, just find me this afternoon. I'll be at the booth. Thanks for the time. I know we're a little bit over, but I really appreciate it. Thank you very much.